Hello, everybody. This is Gigi from Kauai Community College. In this video, I will be talking about integration using partial fractions. Let's start with number one. Okay, so suppose you have the integral of x divided by x squared plus 3x plus 2 with respect to x. Now, when you think about this problem, some of us might think, well, can we just let u be x squared plus 3x plus 2? Well, let's try that. Du will be 2x plus 3 dx, but we only have x right there. And you can manipulate this somehow to figure that out, but I think that would be might be a longer process and it might not even work, right? But what we need to recognize here is we have a fraction that is factorable, meaning we can factor the denominator here to x over x plus 1 times x plus 2, which tells us that we may be able to decompose these two fractions into two partial fractions. Something over x plus 1, then something else over x plus 2. And the reason for that is when we are dealing with problems like these, we know that the integral, okay, so this is an integral that we must know. The integral of 1 over x dx is ln of absolute value of x. So these terms right here, looks like this form here, right? So that's the idea. You break it down into 1 over x looking form so that you can take the integral of, right? So here we would say, then well, let's suppose we are going to go and add our fractions together on the right hand side, and if we did that, then a would need to be multiplied by x plus 2 and b would need to be multiplied by x plus 1, and then the denominators will be the same, so that we now just compare the numerators, meaning it has to equal to the x on the left hand side, right? We will then multiply out the right hand side and combine like terms. So you will have ax plus 2a plus bx plus b. Factor out the x to get a plus bx plus the constant, which is 2a plus b, equals to what's on the left hand side? Well, on the left hand side, I have 1x plus the constant 0, right? X is 1x plus 0. So when I am matching the coefficients here, I would say a plus b will equal to 1. So a plus b equals 1. The constant 2a plus b will have to equal to 0. I said a plus b equal to 1, so I should write 1. And 2a plus b is equal to 0. Now suppose you take the second equation and subtract the first equation from it, you would have a is equal to -1. And if a is -1, from here you would say b is gonna have to be 2. So our original integral can be split into two separate fractions. Okay, the one fraction that we have now can be split into two separate fractions. A is -1 over x plus 1 dx, and the other fraction would be b, and that is 2 over x plus 2 dx. Now it looks like the form of 1 over x dx integral, right? So here we have -1 multiplied by ln of absolute value, and you really don't need to write -1. You can just write negative ln of x plus 1 plus the constant is 2 ln of x plus 2, and don't forget plus c, and that is the final answer to our problem, right? So let's go over the process again. You have one fraction here, right? You have a fractions right here, so that you can go and split into two fractions like this. Then we would have to go and find out what is A, what is B, by combining like terms and matching the coefficients for the numerators. Solve the system of equation, then split the fraction into partial fractions and take the integral. And the most important integral for this unit is integral of 1 over x dx is ln of absolute value of x. Now the other integral that we must know for this unit is the integral of 1 over 1 plus x squared dx is inverse tangent of x plus c. Don't forget the plus c. Okay, so those two in blue are the two integrals that we must know for this unit. And that is it.